We are happy that you are joining for this session today. We want to look at the basics of R programming using the loops and functions. And we have simple coding that has been set up for us using for I in 1 to 10. Then we are saying we print I squared. And when we check at the console after executing the command, when I is 1, when I is 2, it's 2 squared and so on. And the second one, we want for I in 1 to 15, we want to print the word hello world. So it's going to print the word 15 times. And if we execute that, we are able to see the command and the output. Next section, we want to look at simple data frame and what is happening in the data frame. We have for numbers 1 to 12. We track the numbers as I, which is 1 to 12. We get the square, we get the cube. Then we create a data frame to put the number, the square, and the cube. And we are going to name the columns as NOS, SQ, cube, and then we print the result by doing an al bind of the result that we have and the data frame. So let's see how that comes out. And when I say to view, that's the result. I have the number, I have the square, and the cube for the number. And so those are the numbers that I have. I have the square of 12, 144. The cube of 12 is 1728. So that's what I would be able to perform with that. So when I say view results, then they'll appear there. The next thing we want to do, we want to look at numbers not equal to, so for I in 1 to 100, if I you divide by 3 and the remainder is equals to 0, and I you divide by 7, the remainder is equals to 0. So we want numbers whose a number that can be divided by 3 and 7 at the same time. Let's see these numbers from the output. And the first number is 21. 21 divided by 3 is 7, remainder 0. 21 divided by 7 is 3, remainder 0. 42 divided by 3 is 14, remainder 0. And 42 divided by 7 is 6, remainder 0. And that's the number we get. Now, what about number not when you divide it's not equal to 0? For example, now we want the numbers that are not divisible. That's why you put exclamation mark and the equal sign. Not divisible by 3. We know them, starting with the lowest. Let's look at the lowest number that we have. And it gives us an idea. Yes, we have 1, 2, 3 is not there. We have 4, 5, 6 is not there. We have 7, 8, 9. Because 8 divided by 3 is 2, remainder 2. So that's why I'm saying it's not equal to. So print for us those numbers. Another one is on Fibonacci numbers. And we have an example here. Fibonacci numbers, the sequence is 1, 1, 2, 3, 5, 8. So it's 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34, and that's exactly what we want to do with this function here. And down there up to maximum of 10,000, these are the numbers that we have. We have 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. So that's the procedure you would take to come up with that. We want to use the while I is less than 11, print I. And for me to be able to use the while, I need to track the I starting from 1, then I do it at an increment of 1 until the results are less than 11. And so it gives me a printout of numbers between 1 and 10. We can also use the break statement. It prints numbers before the given number. So for example, I have number 1 to 16. I'm saying if I is equals to 6, you break and then you print I. So what does it do? It will print all the numbers up to 5, and then it stops when I is equals to 6. So that condition might hold, it might not hold, depending with what exactly you are doing. You can use the next, apart from the break statement, you can use the next statement also for I in 1 to 15. If I is equals to 6, then next, and then you print. Let's see how the results will come out. And you see the difference. So it does 1, 2, 3, 4, 5. When I is equals to 6, it skips, and then it moves on from 7. So the next will skip that specific number that you want, while the break will stop when you realize that number that you have put there. You can use a repeat loop. Repeat print x is assigned as x plus 1, and if x is equals to 6. So it goes increasing x with 1 until it gets to x is equals to 6. So that is how we can use a repeat loop. And you can see it gives me 1, 2, 3, 4. If it's at 6, it will stop there. So these are different ways of developing small codes that can help you automate your processes of data analysis, which is very important. The other thing we want to look at is what we call functions, user defined, calling a function. I'm calling this function Davis, and I'm saying a function is a function of A. Then I say for I in 1 to A, then B is assigned as I squared, then I want to print B. Now, how does this work? So if I was to execute the command, you see that there's no results. So I can decide to define the function. And there are ways of doing that. If I was to say Dave is 5, what have I done? I've said Dave is 5. And when I say Dave is 5, what I'm basically doing is I'm defining my A to be 5, because I'm saying Davis is assigned as a function A. So when I say Davis 5, I'm saying I want my A to be equals to 5. Then I say for I in 1 to 5, then B is equals to I squared. So for I is 1, B will be 1 squared, which is 1. For I is 2, B will be assigned as 2 squared, which is 4, and then it's printing. I could have decided instead of say print B, I could have said I want to assign I to be I squared, and then I remove this. It will still have worked for me, and it should work for me. So I'm going to rerun the code again, and here I'm going to type maybe Davis, and maybe let me put 6. Allow me to do that, and you can see we are getting the exact output. So these are what we call user defined or calling a function. So, and this is what you get. So we move on to the next part, which is normalizing, and I want to normalize that. And I have defined a sequence of numbers, y1 as a sequence of numbers from 1 to 9 with a difference of 1. And then I have y2 and I have y itself. Let's see how the numbers look like. Yes, from 1 to 9. And then the second set of numbers, you start from 10, reducing by 2 up to negative 10. And then the y definitely is you sort out, you put all those numbers together, but you sort them from the lowest to the highest. Then I say normalize the function y. So what this function will do is it will just give me a normalized uh, set of numbers, which is y that you have been given. And remember, these are my y values. So what I do is I put them in an interval of 0 to 1. This is also a function that is also used quite a lot in machine learning or data science when you're trying to normalize your numbers in some of the computations.